An electrical panel was observed in a restroom, specifically to the right of the toilet in a hydraulic pump repair shop. Emerging from the bottom of the panel is a 2-inch white polyvinyl chloride, or PVC, plumbing pipe. This pipe then executes 2 back-to-back 90-degree turns using street Ls, which are compact 90-degree fittings. Following these turns, the pipe disappears either into the floor or the back wall situated behind the toilet. Considering this configuration, several possible purposes for the plumbing pipe can be considered. Firstly, the pipe could be intended to drain condensation that accumulates within the electrical panel. Electrical panels, especially in humid environments, can experience condensation. This moisture needs to be removed to prevent corrosion and electrical faults. Secondly, the pipe might serve as a vent for the panel. Some electrical components generate heat, and proper ventilation is necessary to dissipate this heat and prevent overheating. The pipe could facilitate airflow, drawing in cooler air and expelling warmer air. Thirdly, the pipe could be supplying water to an internal component located within the panel. This is less common, but conceivable if the panel houses equipment that requires water for cooling or some other operational function. The proximity of the electrical panel to the toilet allows for relatively easy access to the panel for maintenance and servicing purposes. However, this arrangement also presents potential safety concerns due to the close proximity of water and electrical equipment. Here are some detailed considerations regarding the potential purposes of the PVC pipe connected to the electrical panel. Firstly, condensation drainage. In many environments, electrical panels can accumulate condensation due to temperature fluctuations and humidity. The presence of sensitive electronic components inside the panel makes it crucial to manage this moisture effectively. A 2-inch PVC pipe may be connected to a drain inside the panel to collect and remove this condensation. In such a setup, the pipe would need to be sloped correctly to ensure proper drainage, and it would likely terminate at a suitable drainage point, such as a floor drain or a connection to the building's plumbing system. Secondly, ventilation. Ventilation is vital for electrical panels to prevent overheating, especially if the panel contains devices that generate significant heat. Heat buildup can degrade the performance and lifespan of electrical components. The PVC pipe could be part of a ventilation system designed to circulate air through the panel. In this scenario, the pipe might act as an exhaust vent, allowing hot air to escape. If the pipe is part of a ventilation system, there would likely be corresponding air intake vents elsewhere on the panel to facilitate airflow. Thirdly, water supply. Although less common, there are situations where an electrical panel might require a water supply. For example, some specialized electrical equipment, such as certain types of cooling systems or industrial devices, may use water for cooling or other processes. If the PVC pipe is supplying water, it would need to be connected to a water source and include appropriate valves and controls to regulate the water flow. The water supply would also need to be protected against backflow to prevent contamination of the potable water system. Considering the potential safety and code compliance issues, it is important to evaluate several factors. Firstly, electrical code compliance. The installation of an electrical panel in a restroom and the integration of plumbing elements must comply with relevant electrical codes, such as the National Electrical Code, or NEC. The NEC sets standards for the safe installation of electrical equipment and wiring, including requirements for clearances, grounding, and protection against physical damage. Secondly, plumbing code compliance. The plumbing connections associated with the electrical panel must comply with applicable plumbing codes. These codes address issues such as backflow prevention, drainage, and the proper materials and methods for plumbing installations. Thirdly, safety considerations. The proximity of electrical equipment and plumbing in a restroom environment raises safety concerns. Measures must be taken to prevent electrical shock hazards and ensure that the installation is safe for users. This might involve proper grounding, the use of ground fault circuit interrupters, or GFCIs, and other safety devices. Now let's delve into additional details about the electrical panel itself. The fact that it is a Cutler Hammer panel is relevant because Cutler Hammer, now part of Eaton Corporation, is a well-known manufacturer of electrical distribution and control equipment. Knowing the brand can help in assessing the quality and features of the panel. The panel size and capacity would determine its suitability for the intended application. Electrical panels are typically rated based on the maximum current they can handle, as well as the number of circuit breakers they can accommodate. The physical dimensions of the panel are also important, especially in a confined space like a restroom. The panel's construction and materials play a role in its durability and resistance to environmental factors such as moisture and corrosion. Panels designed for use in damp or wet locations are typically constructed with corrosion-resistant materials and include features to prevent water from entering the enclosure. Let's also consider the street Ls. Street Ls are a type of plumbing fitting that features a male fitting on one end and a female fitting on the other. This allows them to be directly connected to other fittings or pipes without the need for an additional coupling. The use of street Ls in the PVC pipe configuration suggests that space constraints might have been a factor in the installation. Street Ls are often used in tight spaces where a standard elbow and coupling would be too bulky. In terms of the back-to-back 90-degree turns, this configuration of two 90-degree turns in close proximity can create significant resistance to flow in a plumbing system. This is because each turn causes a pressure drop, and the combined effect of two closely spaced turns can be greater than the sum of the individual pressure drops. If the PVC pipe is intended to drain condensation or provide ventilation, the back-to-back turns could reduce the effectiveness of the system. The National Electrical Code addresses the installation and safety of electrical panels in various environments. Some key sections of the NEC that might be relevant in this scenario include firstly Article 110. NEC Article 110 covers the general requirements for electrical installations, including requirements for workmanship, equipment listing and labeling, and access to electrical equipment. Secondly, Article 240. NEC Article 240 addresses overcurrent protection, including the requirements for circuit breakers and fuses. This article also specifies the conditions under which overcurrent protection devices must be readily accessible. Thirdly, Article 312. NEC Article 312 covers cabinets, cutout boxes, and meter socket enclosures. This article provides requirements for the installation and use of these enclosures, including requirements for working space and protection against physical damage. Fourthly, Article 408. NEC Article 408 addresses switchboards, switchgear, and panel boards. This article provides detailed requirements for the construction, installation, and wiring of these types of equipment. Here are some potential code violations that could arise from this installation. Firstly, working clearance. The NEC requires adequate working clearance around electrical equipment to allow for safe maintenance and repairs. The panel's proximity to the toilet might not provide sufficient working clearance, especially if the toilet is in use. Secondly, damp or wet locations. If the restroom is considered a damp or wet location, the electrical panel must be suitable for that environment. This might require an NEMA4 or NEMA4 X-rated enclosure to protect against water ingress. Thirdly, physical protection. The NEC requires electrical equipment to be protected against physical damage. The PVC pipe exiting the bottom of the panel could be vulnerable to damage, especially if it is exposed to traffic or other hazards. Fourthly, grounding. Proper grounding is essential for electrical safety. The electrical panel must be properly grounded to provide a path for fault current to return to the source, which helps to prevent electrical shock hazards. In addition to the NEC, local building codes and plumbing codes might also apply to this installation. These codes can vary depending on the jurisdiction and might impose additional requirements or restrictions. Here is some more background on PVC pipe. Firstly, material properties. PVC is a thermoplastic polymer that is widely used in plumbing and electrical applications due to its durability, corrosion resistance, and low cost. PVC pipe is available in various sizes and schedules, with different wall thicknesses to suit different pressure and temperature requirements. Secondly, joining methods. PVC pipe can be joined using a variety of methods, including solvent welding, threaded connections, and flange connections. Solvent welding is the most common method for joining PVC pipe in plumbing applications. Thirdly, applications. PVC pipe is commonly used for potable water distribution, drainage, waste, and vent, or DWV, systems, and electrical conduit. It is also used in a variety of industrial and agricultural applications. Now, let's consider the possible implications of the pipe going through the floor or wall. If the pipe goes through the floor, it would likely need to be supported to prevent sagging or damage. The point where the pipe penetrates the floor would also need to be properly sealed to prevent water or moisture from entering the building structure. If the pipe goes through the wall, similar considerations would apply. The pipe would need to be supported, and the penetration point would need to be sealed. Additionally, the pipe would need to be protected from physical damage, especially if it is exposed to the elements on the exterior of the building. Let's consider some additional factors regarding the electrical panel's location. Firstly, accessibility. While the proximity to the toilet might provide easy access for some maintenance tasks, it could also make it difficult to work on the panel if the restroom is occupied. Additionally, the confined space could make it challenging to maneuver tools and equipment. Secondly, environmental conditions. Restrooms can be subject to high humidity and temperature fluctuations, which can affect the performance and lifespan of electrical equipment. The panel's enclosure would need to be appropriate for these environmental conditions. Thirdly, aesthetics. The presence of an electrical panel in a restroom is generally not considered aesthetically pleasing. The panel could be an eyesore, and it might not be in keeping with the overall design of the restroom. Furthermore, let's look at potential remediation measures. If code violations or safety concerns are identified, several measures could be taken to address these issues. Firstly, relocation. The electrical panel could be relocated to a more suitable location that meets code requirements and provides adequate working clearance. Secondly, enclosure upgrade. The panel's enclosure could be upgraded to a NEMA 4 or NEMA 4X rated enclosure to provide better protection against water ingress. Thirdly, physical protection. The PVC pipe could be protected from physical damage by installing a guard or shield around it. Fourthly, grounding improvements. The grounding system could be inspected and upgraded to ensure that it meets code requirements. The information provided suggests an unusual and potentially non-compliant installation. A thorough inspection by a qualified electrician is recommended to assess the safety and code compliance of the installation and to recommend appropriate corrective measures. Remember, electrical work should always be performed by qualified personnel to ensure safety and compliance with applicable codes and regulations. It is crucial to prioritize safety when dealing with electrical equipment, especially in damp or wet environments. If there are any doubts about the safety or compliance of an electrical installation, it is always best to consult with a qualified electrician. Proper installation, maintenance, and grounding are essential for preventing electrical shock hazards and ensuring the safe operation of electrical equipment. Finally, the use of appropriate personal protective equipment, or PPE, such as gloves and safety glasses, is recommended when working on or near electrical equipment.